Okay, number 12. Y equals x squared minus 3x minus 1 at x equals 0.
So you said number 12 and I'm like, wait, that's it.
Huh?
Like we're only at number 12?
Oh.
That's all we've done?
We did several yesterday.
Yeah.
All right, so remember when we're doing this, it's a plus h is going, or wait, is it a plus or minus? Plus. It's a plus h minus f of a. That's why I always have to think about which order the signs go in. So in this case, it's 0, so we're really just going to be plugging in h. I'm not going to write the 0. Just know that that's what would be there. So the limit as h approaches 0 of h squared minus 3h minus 1 minus, now evaluating at the point 0. So 0 minus 1 all over h.
Keep forgetting that we have to put it over h. Trying to save space here.
So then -1 and the -1 all cancels out. So I'm left with the limit as h approaches 0 of, I'm going to go ahead and factor out an h times h minus 3 over h. Make sure we're tracking before I keep going, because I just did a lot in one thing. I cross out the negative and the positive 1, and then I factor out an h, where we're at.
Wait, you mean the negative and the negative one?
Yeah. So h is canceled. The limit as h approaches 0 of h minus 3 is -3. So remember,
So like we just disregard the h that's there and just...
no, we plugged in 0.
No, I mean like when we cancel stuff, we disregard that h that's in the parentheses. Or
Well, I can't cancel it because
Oh.
it's...
0 for you.
yeah, okay, I understand.
So this is the
My-
slope
my
of the
brain did that.
tangent.
That's the kind of thing I would say, Josh. You can't take outside and that kind of stuff.
Josh is doing some Virginia level stuff over here.
It's ever since I used his calculator.
I just wrote slop of tangent.
See, I would never do that.
All right.
I'm available for notes. I'm still available.
So we're doing this at the point 0 and f of 0. F of 0 is -1. Basically, whatever ends up being in the parentheses is your f of that value, so you can just plug that in. So 0, -1. Slope is -3. Point slope form, y minus negative, so +1 equals -3 times x minus 0. Subtract the 1 over, y equals -3x minus 1. So this is the tangent. Then the last thing I need is the normal. So we still have the same point, 0, -1. What would the slope of the normal line be?
1/3.
Yep, 1/3. So it's perpendicular to it. So y plus 1 equals 1/3 times x minus 0. So y equals 1/3 x minus 1.
Is is it always going to be 0 for the x? Like when you're doing the...
I just wrote 1/2 again.
No, that's just because this was the point that they told us to plug in. So this one, they said at x equals 0.
those are like
So it's at the point 0 and then whatever f of 0 is.
Okay.
That just -1 was what it happened to be in here, and that's what it's going to end up being. But like this one up here, our x value, whenever I get back to it, was 1. So that's why. So it just depends on what x value they give you.
Okay.
Let's see. 16 says, determine whether the curve has a tangent at the indicated point. If it does, give it slope. If not, explain why not. Oh, okay. I was trying to register what was happening here. F of x equals, and this is going to be piecewise function, negative x for x less than 0, x squared minus x for x greater than or equal to 0
I don't know if I like these piece
at x equals 0.
What does piecewise mean?
It just means there's like multiple pieces of the function.
Okay.
Thanks. And you do each piece for its domain. It's that one's domain is over, you go to the next one. If there is next one.
All right, so basically what we do is we're going to take each of these functions, because these are technically two separate functions, so negative x and then x squared minus x, and we're going to take the limit like we did to find the slope up here. So I'm going to find the slope of each one of the pieces individually. If the slope is the same, then it has a tangent at the point. If it doesn't, then if it's like they're not the same, then there's not a tangent. So let's see. So I'm going to do the limit as h approaches 0 of, now the ones that we're doing are both going to be 0, but just for reference, I'm going to do the a plus h part. So I'm going to do 0 plus h in for, so I'm going to start with the negative x piece. I'm just going to note over here that that's the function I'm working with for right now so that we know where I'm at. So of negative 0 plus h minus at 0 is 0. Huh?
Is this over anything?
Yeah. Over h. It's just like the way we did slope before in part A of the last two problems. Now, again, you wouldn't need to put in the 0 like the a plus h part. I'm doing it because there's some of the problems that actually have a number that you're plugging in, like 2, or there's trig 1 that you're plugging in like pi over 4 or something. So that's why I'm writing it. It works the same way even if it's not a 0. This is just for reference. So this ends up being the limit as h approaches 0 of negative h over h. H over h reduces to 1, so this is going to come out to be negative 1. So
you're just plugging in, like, so since it was negative x, you did the negative, and then, like, you made x, that it's 0.
X is the a plus h part. So yeah, so this is the f of a plus h, and then this is f of a all over h from the like original formula that we had. So then we do the same thing with the other one. So the limit as h approaches 0 of 0 plus h quantity squared minus 0 plus h minus, and then 0 minus 0 all over h. I don't know. Just the letter the book uses. So this would be the limit. I'm just going to shorten it. The limit as h approaches 0 of h squared minus h over h. Or or I can factor an h out. H times h minus 1 over h. And so then when we cancel and we plug in, we get -1. So slopes are the same. So we have a tangent. And it wanted us to tell what the slopes were, but we had already found them, obviously, through that. So I don't really know of a way to do this other than doing it this way. So anyways. I was going to do another one at 0, but maybe I'll try the trig function one. Let's do that one. Otherwise, I'm going to end up doing an odd one. I'd rather leave odd for y'all and do even. So f of x equals sine of x, or well, that's piecewise again. Sine of x for 0 less than or equal to x less than 3 pi over 4. Cosine of x, 3 pi over 4 less than or equal to x less than or equal to 2 pi. And this is at x equals 3 pi over 4.
Love pie. Tasty.
This one's going to be interesting.
I don't like those words.
What? Interesting.
I'm not sure I like this problem. Thought I did, but I don't know that I do anymore.
If you don't, then I definitely don't.
All right, let's just start and see what happens.
Things and problems.
We may have to do a follow-up to this problem tomorrow. So as h approaches 0, so we'll have, oh, wait, yes,
Oh.
still as h approaches 0,
Oh.
but x is 3 pi over 4. That's what I need to remember. X is 3 pi over 4.
So it's always going to be as h approaches 0?
Yes, that's the definition, limit definition.
Okay. So h always approaches 0, but we plug in the x.
But yeah, we plug in this value. So, okay, it is the sine of 3 pi over 4 plus h minus the sine of 3 pi over 4 all over h It's not going to be helpful to you.
I know, but maybe I just wanna.
I suspect we're going to need a sum and difference formula.
God.
Why did I decide to do this problem? I don't have this one already worked out. Okay. We'll just try it. We'll see what happens. The limit as h approaches 0. Okay, first and foremost, what is the sine of 3 pi over 4?
Wait, what?
Sine of 3 pi over 4.
Okay, so that's
This
like,
way.
Yeah, that's that way. So that's
What do you think?
negative.
1/2?
Negative. It's a negative.
Pi over 4s are always what?
Oh, it's always the 2 one.
Yeah.
Negative square root of 2 over 2.
Sine is y.
Oh.
Sorry.
Positive
Yeah,
square
I
root
was
2
I
over
was
2.
saying it's negative, and then it's like no, that's not negative. So I said it's negative.
So it's root 2 over 2, but the sign, S-I-G-N, is negative, so
Oh, so
there.
it is.
So it is going to be negative, but that's not why.
We were just thinking ahead.
Okay,
Weren't you?
sum and difference formulas.
Mm.
Oh, it's sine of whatever plus cosine or
Not plus.
whatever.
I think it's times.
Sine, I think it's.
I think it's
sine,
sine A
cosine
cosine
plus
B
Plus cosine sine.
is sine the same sign.
Like sine A
Oh.
cosine B plus cosine A sine B.
Yeah, but is it a plus or a minus in the middle?
It's a plus because it's sine.
Oh.
Sine is the same sign.
Oh yeah,
Cosine
sine
is the opposite
same.
sign.
Yeah.
Oh, dear.
Sine is the sign.
Interesting.
Do you get it? Wait, why are we setting it equal to? It was already negative.
I was moving something over and it just happened.
Okay, 3 pi over.
Cash. That's what it looks like.
That says cosh.
I know. I said that's what it looks like.
Oh wait, why does that say sine of 3 pi over? Why did you write your 4 upside down?
I didn't. I just didn't draw the whole thing.
iPad mistake.
Hold, please. I need to check the answer to this and make sure I'm not going like on a wild goose chase here because I kind of feel like I am at the moment. Oh my gosh.
Is it easy?
Did we
Or
not
is
have to
it-
do that?
The limits aren't the same.
What are they?
Tell us. Let us like.
Wait, what
Let
limits
us
are
suffer.
there? Oh yeah, they both have different things.
There's a discontinuity because what is the sine? The sine of 3 pi over 4 we said is root 2 over 2. What's the cosine of 3 pi over 4?
Negative root 2 over 2. Negative.
So
2
there's a
over 2.
discontinuity there.
So we didn't even have.
So
to
we
do
didn't
it.
even need to do it this way.
Well, it was good to review the whatever those things were.
It's fine. We're just gonna take the L on that. And
Wait, so why didn't it work?
so if we were graphing it, the sine of 3 pi over 4 is root 2 over 2. But the cosine of 3 pi over 4 is negative root 2 over 2. These aren't the same, so it's discontinuous because the left-hand limit and the right-hand limit aren't the same.
Oh, okay.
So if it was like pi over 4 or like 5 pi over 4, then it would be good.
If it's something, yeah, that they're the same at.
Aren't those the only 2 ones that they're the same at?
Probably.
So is that the final answer?
Yeah.
Hooray.
Hooray.
Love that.
Me too.
All that work for nothing. Okay.
Don't you just love it when you put in so much effort and it just doesn't pay off?
Let's see. Instantaneous rate of change. 24.
Is this a long problem? I just need to know if I can flip the page.
I have it on like probably depending on how if you're doing your limits on 2 separate lines or 1 line, like I did mine on like 2 separate and it would be like 6 to 7 depending on if you're okay with doing it like to the side one time.
Flip.
I try to keep my limits all on 1 line.
All right, so 3t squared plus 2t at t equals 3. So this is going to work the exact same way the previous ones have worked. Instantaneous rate of change is pretty much just slope. So limit h approaches 0 of 3 times a plus h, so 3 plus h, not t, squared plus 2 times 3 plus h minus, I'm going to bracket this off since there's multiple pieces here, 3 times 3 squared plus 2 times 3 all over h.
Love backwards on just 1 on the H.
Wait, just to make sure I know what I'm doing, can you like explain one more time how you're like putting that in?
Yeah. So I have this function here.
Okay.
Everywhere there's a t, the first time through, I'm doing 3 plus h. It's the a plus h part. So now instead of it being x is equal to something, t is equal to something.
Okay.
So a is just kind of a generic placeholder when we're plugging something in. So this is 3 plus h. So I have 3 times 3 plus h squared, that's this first part, plus 2 times 3 plus h, that's the second part, minus f of a, so that's evaluating this function at 3. So I'm just plugging 3 in directly.
Okay.
That's this part, and then all over h, which it'll always be.
Just gotta remember that whatever that letter there equals, that t equals a.
Now this is a perfect square trinomial. To save having to write the whole thing out, what does this factor into?
3 plus h. Wait.
27.
3 plus h
Well,
squared is 27.
no, I'm just thinking of
H squared.
Ignore this
plus-
one.
bruh. So we have 9 plus 6 h plus
Plus
h
h
squared.
Okay, there we go. Now, when I do the next line, then I can go ahead and multiply by 3. So that's going to be 27 plus 18h plus 3h squared plus 6 plus 2h minus, over here, what do I have? 27 plus 6, 33. Now, and well, don't forget the all over h part. Sometimes I just like drop the over h part till the end and then I put it back because why not? So as far as stuff canceling, 27 plus 6 is 33, so minus 33, that's gone. So then I can factor out an h. So I'm going to have 20h, but I'm going to factor out an h. So the limit as h approaches 0 of h times 20 plus 3h over h. H's cancel. 20 plus 3h, so evaluate it at 0 is just 20. And units are feet per second. So that's the instantaneous rate of change for this. So a little different way of doing something we do in physics.
That's like
Huh? All right, so we'll do, that's unfortunate, like one word problem with this stuff tomorrow. I thought there were still like 2 or 3 problems left, and I was like, oh, there's one, and then there's one that I give you a formula for. Isn't that nice?
that's all right.
Anyways, we'll do that tomorrow, and then y'all have time to work on these problems, because, I mean, we're ready for a quiz, I would say Friday.
I bet those 8th graders will be terrified if they walk in and see that.
Sometimes they come in and they're like, what's on the board? But